Hello, welcome back. We can continue our discussion on solving differentials by using separation of variables. So let's take a look at an example like number 3. Now this one should be a little bit easier for us. We don't do the exponential thing, and I know because the y here is squared. So what we're going to do is we want to solve for y. So we're going to divide by that y squared. So that's going to give me 1 over y squared. I'm going to keep the x over here. This stays with the dy, and I'm bringing my dx over, so this becomes x dx. When we integrate now, remember we're solving a derivative, so we got to take the antiderivative here, and be careful here. This is really y to the negative 2 dy, and of course it's just x dx. When we integrate y to the negative 2, this is going to become negative 1 over y, just because we're just adding 1 and dividing, so that becomes a negative 1, so we put on bottom, equals x squared over 2 plus c1. Now, I don't like the negatives. I'm going to get rid of the negative. I'm going to divide everything by a negative 1 right now. And that's going to become a positive 1 over y equals negative x squared over 2. And you might remember from before, the c1, we're just going to change its subscript, c2. Change by dividing by a negative, we don't, it's just a constant, so we can just leave it. Now, here's the tricky part. We have to solve for y. So there's two ways we can do this. Option one is I can just flip it. But if I flip it, I have to put a 1 underneath all of this. And that's going to give me y equals 1 over negative x squared over 2 plus c2. And now it's not that bad. I just got to multiply top and bottom by my common denominator, which is a 2. So therefore, we would get y equals 2 over, and distribute here. If we distribute here, we're going to get negative x squared. And over here, we would get 2 times c2. But again, I don't have to write 2 times c2. I could do that, or I could just put down c3 if you want to. And if you forget the subscripts, don't worry. All you got to do is remember, if I multiply c2 times a constant, that's just going to equal another constant is really what's going on there. And there is our answer. That's option one. Now, option two, which is probably the more consistent way, is if I have 1 over y equals negative 1 over x, whoops, sorry, other way around, where I have negative x squared over 2 plus c2, I can do a common denominator. Just put a 2 underneath there, and that's really all I have to do, honestly, because the constant is just a constant. If I do c2 over 2, I don't have to worry about multiplying this by 2 because it just stays another constant. And if not, we can just make that, oh, look, make that a c3 if you want. And now I got a common denominator. I can rewrite my right side of negative x squared plus c3, because remember we multiply by a constant there, over 2. And if I flip it, I get 2 over negative x squared plus c3. And if you notice, both options work. They're both the same, so whichever you choose. All right, number 4. Let's take a look at number 4 here. Now we're going to solve with initial condition. Remember, this is now saying find c, find our constant there, the constant of integration. So here's our differential equation, dy dx equals x squared times y plus 1. Who knows? Maybe this exponential equation describes the motion of a planet through the solar system. So what we want to do is be able to find out, well, where is that planet going to be at a certain given time? And that's what differentials allows us to solving, and that's what allows us to do. So it's really kind of a neat technique that we use. So we're going to separate our variables. So I'm going to bring the y plus 1 over to the left side by dividing, and I'm going to bring the dx over by multiplying. Keep the x squared over here. We're going to keep the x squared on the right side. So we would get 1 over y plus 1 equals, whoops, sorry, forgot my dy, don't forget the dy, equals x squared dx. Now remember, if you don't have this step right here, you can get no point. We can't give you any credit for it. Make sure you show that step every time. Now we're ready to integrate. Of course, this is our u substitution. Oh man, gotta do some u substitution here. All right, so u is y plus 1. My du is dy. Oh, that's nice. So when I rewrite this, we would get 1 over u du, which is just a natural log of y plus 1 in this case, equals, and now this one, x cubed over 3 plus c1. Now come our favorite part, exponentiation. Sounds like it's a spell in Harry Potter world, right? So we're going to exponentiate both sides just to get rid of that natural log there. And that's going to give me absolute value, y plus 1 is, and remember, this is that new algebra step, right? We're going to, since I am multiplying, since I'm adding the exponent, I can write this as the product of two exponents times e to the c1. And this is what we wanted. That's what we wanted right there. So we're now going to say let e to the c1 equal c2. And what that allows me to do is rewrite it. So I can actually go straight to my answer here. I can get y plus 1 equals, bring my c2 to the front, c2 e to the x cubed over 3. But remember, this is going to be plus or minus because we're taking the absolute value. And there is our general form. So now, again, we want to find c2. We're going to use the initial condition, 1, 3. That's what they gave us. But notice here, look, y is positive. So that's the one we want to use, the positive y value. And so let's see here. So we can go y plus 1 equals the positive c2 e to the x cubed over 3. And then just plug in your point. Y is 3, so I get, oops, over, what was it, over 3 there. There we go, got the lead out. So y is 3, so I'm going to go, that's 3 plus 1, which is 4, equals c2. X is 1, e to the 1/3. Oh, just dividing. C2 is 4 over e to the 1/3. It's ugly, but it's okay. So therefore, our equation, y plus 1, would equal 4 over e to the 1/3 times e to the x cubed over 3. And there's your answer. You can leave it like this. Don't simplify. But if you want to, you can go y is equal to 4 e to the x cubed over 3 minus 1/3 minus 1. If you want, if you're brave. So you don't have to do that if you don't want. All right, let's take a look at number 5 now. All right, number 5. Let's take a look here. Same thing, solve the initial condition. Given the initial condition, solve the differential equation. Same thing. I want to separate my x and my y. So I have to divide by y because it's on top. And I'm going to multiply by the dx to bring it over. So that's going to give me 1 over y dy equals 1 over x squared dx. So when we integrate, oh no, the left side's pretty easy. That's just our natural log of y. You never thought natural log would be the easy one, right? But the right side, be careful. This is our x to the negative 2 dx. That is not natural log, so be careful. Not natural log. So we get the natural log of the absolute value of y equals, and we talked about this before, this is just negative 1 over x plus c1. Exponentiate, there we go. So we're going to get the absolute value of y equals, don't forget, we're going to write this as a product of two of the same bases, e to the c1. And then we'll say our motto, let my people go, e to the c1 equals c2. And I can get this. Y is equal to plus or minus, I'm going to put my c2 into the front, c2, and that's just e to the negative 1 over x. Remember, I'm just doing 2 steps at once. I am undoing my absolute value, right there, and we are replacing e to the c1 with c2. But you got to remember, you have to have this step right there. Okay, so let's go ahead and now solve for c2. So find c2, and our initial condition was just 1, 3, and right over here, y is positive, so I want the positive one. So we can take y equals the positive c2 e to the negative 1/2 x, negative 1x, 1 over x, sorry about that, it's terrible. So plug in your value, y is 3, we get c2, x is 1, so this becomes e to the 1, negative 1 in fact. So c2 equals 3 over e to the negative 1, and now I get my equation. Y is equal to 3 over e to the negative 1 times e to the negative 1 over x. And that's really it. There's your equation right there. And you can leave it like that. You can actually have negative exponents for these because these are exponential equations. But if you don't want to, like, oh, look, that just goes on top. This, if you say, oh, look, this just goes up on top here, you can, of course, write that out. Right there, sorry about that. And we would get y equals 3 times e to negative 1 over x, or y is equal to 3 e to the 1 minus 1 over x. All of those would be okay to use. All right, hope you enjoyed the video, and I will see you later. Go